Hello, my name is Daisy Jeremy from Simulation Software Group. So I'm going to share with you how to tune a PID. So I'm welcoming you to enjoy this video. It is very important. So in fact, the PID controller, like 85% of industry in the world use this PID controller. So it is very important as a future engineer to see how can control the PID. The previous video I have showed you how to graph the different transfer function. So in my video I'm going to start where the previous one ends. So from the previous transfer function we have get. So we need. So I'm going to start with the value of h, which will help me to get the feedback, because we're going to see to control our feedback, to control our system closed loop. So there is different advantages for using the feedback, but this video we're going to see how can control automatically. That's why we need to see how you can use automatically. Let me h equal to 1, then the values of k manually, values of kp equal to 1, ki equal to 0, and kp and I mean kd equal to 0. Then after this one, we have to define our PID in our simulink or in our MATLAB. So let me use Tn equal to PID, then bracket, then Kp, Kd, I mean Ki and Kd. So this is our PID controller. So we need to tune it. So to tune it is to vary different parameters of K, P, Ki, Kd properly and give it a stable system. So we can define our system controller. Let me use controller equal to feedback, then bracket feedback bracket our Tn as PID, then using our transfer function TR, and then and even feedback, our feedback, which is equal to h. Then we need to graph it. Graph, I mean step bracket, step our controller. So the reason why I use step, it is the inputs. It is like input. It may be ramp, so it may be other different signal, but here I'm going to use step. Then after this, come on the editor and run it. So after running, so in the command window, we get this P. We get the different value of N, D, Ki, Kp, and our controller P. It is indicated that we can see that here it is P only. So it is because our system contains Kp, Ki equal to 0, and even KD equal to 0. Yes, so we need to run this program. So already we have run it, and come and see the different graph. This is our graph we obtain after running it. So we need to make it automatically, because we cannot know the different value of Ki, Kd. Let me use 1, even here 1, and run it again. You can see the other control, which is called now it is called PID controller. You can see this PID controller here. So after this, let me use it use automatic one to see how can tune it automatically. I may cut this one, then come on this in the icon called this icon up, and click on tune. After click on tune, come on plant and port, then come to transfer function, import transfer function, and come to input. So you can see this is overshoot. This is as we have explained in the previous video, and this is the settling. We need to reduce this overshoot and make our system stable. So here, as you can see, the type you have P type, so you have to come and select PID type, and you can see the outlook of this one. So come on this and show different. Come on this icon, click on it. Will show the different values of Kp, Ki, and Kd. So, and even rising time overshoot. Before you start, you can see that you have a big number of overshoot, and settling time, maybe settling time 1 second, and rising time. So we need to make this system stable by coming here and start adjust depending on your calculated values you want to reach on, because the simulation is first you have to calculate, and then come and running it with different values. So here you can see, you can adjust as I'm adjusting transient behavior or response behavior. This give me some values which is stable. Like, you can come and try to minimize some overshoot by using this rising time and transient response. So until you reach on your stable system. Let me take this as our system, which may have the rising time of 0.1 and settling time 0.4, and my overshoot have been reduced. Before I have like 80%. So these values I'm going to copy it and run it in our MATLAB. So let me run this value in MATLAB and to see our new graph. So after obtaining the different values of Kp, Ki, Kd, so you need to paste these values and put in our M file or in our editor. This is already I have done it. So just you change these parameters of Kp, Ki, Kd, and this will give us our system as stable. Come on home, come on editor and run it again. So this is our, if you're going to buy, you will buy this controller which contain these values, so that it can give you the stable system. As you can see, after running it, you can have our system which is somehow stable, and and also you may use this this